Hello and welcome back. So we're doing another organic chemistry video. We're doing the bond line structures and Lewis structure practice before we start getting into the heavy part of organic chemistry, just working on our foundation again. So I am actually using I think they're called Astro's headset from my video gaming. I kind of want to eliminate this pen clicking on the screen. It kind of bothers me too watching, so I'm going to see what we can do. So I think here I got 6 problems that we're going to do. We're going to go from like condensed form to Lewis structure, the bond line, and vice versa, and see how it goes. So let's get this out of here. I'm going to start with problem 1. I'm going to give you this condensed formula. And then we're just going to try to work our way into that Lewis structure. So we're going to go step by step. So if I know I got a CH3, that just goes right at the end. Okay, that's good. Then we know in the middle of a chain, I'd have a CH2. It looks like there's another one. And then I have my carbon going on here. Alright, so I know that's not the end of the chain, and it doesn't look like this carbon has any hydrogen, so I'm going to need 2 oxygen going. And then I guess this CH3, I kind of get to pick where it goes. So we should know that this isn't fully done yet. This carbon right here only has 3 bonds, and we know it needs 4. These oxygens, we didn't account for valence electrons or anything. So if we look, we'll go in red right now. So if I were to complete each octet, I'd have a unbonded electron there. I'd have 2 on this oxygen. I get 1, 2, 3, 4, 5, 6 for a formal charge. And then I get 1, 2, 3, 4, 5, 6. Alright, well, we see here, maybe these 2 bonds right here can go into a double bond. We know that carbon, oxygen, nitrogen, and sulfur, among other things, can double bond. So I'm just going to rewrite this. My CH2, CH. I kind of hope this quality sounds a little better, because personally I don't want to buy a podcast mic right now, especially when right now, I'm rocking at no views. It's the summer, and I'm just kind of doing this for my education, for maybe someone else's, maybe someone will enjoy it. So we got our condensed formula right here, condensed. We have our Lewis structure, and we should know how to do that from Chem 1. Now from organic chemistry, kind of getting that bond line structure, I need to account for 1, 2, 3, 4 carbons. So I'll do our zigzag. So that's 1, 2, 3. Got my 4th carbon right there. I know now I've got my oxygen. I'll just draw it like this. Then I got my last bond right there. I know I have a double bond. Yeah, it's fine. Not a big deal. And there you have it. If you really want to be picky, there's 1, there's 2, there's 3, there's 4, and there's 5. Let's get that out of there. This makes it messy. Oh, going the wrong way, sorry. Alright, next problem. I'm going on to number 2. Come on. So, I'll give you a Lewis structure again. Go to my CH3, CH. Imagine if this isn't recording right now, that would be devastating. Not devastating, but kind of be a pain to do it again. I'm working on a couple videos today. So bond line structure, pretty easy. You got 3 carbon, 1, 2, 3. And then I get my O right at the end, my OH. And if you want, we know there's two valence. You know there might be a bond right there, but it's just nicer to go OH. So what do we got? We got 1, 2, 3 carbon, oxygen at the end of this bond, and we're good. Nice, quick, easy one. So now we're gonna start naming later, but we got decane here, just 10 carbon chain. So C10, H22, and let's just start the bond line structure. That would be nice and easy. So you're gonna know that this is saturated. There'll be this thing. It's like CX y to the forget 2x plus 2. That's the most that you can get. And we see 10 times 2 is 20 plus 2 is 22. So we're just going to see a chain here. Just kind of a quick thing. We'll go over those types of things later. And now just kind of draw it out. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Kind of quick exercise. Now we can draw the condensed form. If you want, just kind of pause the video and put it out or not. Just follow along. So we know the ends are CH3. Got a CH2, CH2, all the way down. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. And at the end, you get a CH3. If you add that up, that's C10H22. So I'm going to give you, so let's draw from methanol. Go on to problem 4. We got methanol. Methanol is CH3OH. Let's draw the Lewis structure, and let's put in all our valence electrons. Got a carbon in the middle. Get 3 hydrogen going on here. Got my oxygen bonded with its hydrogen. And we know oxygen, that formal charge to be 0 needs to be 6 total things to it. So we have 2 bonds, so we got 4 to go. I'm going to have 4 valence electrons. Problem 5. So for this problem, we're going to add enough hydrogen to satisfy each carbon, and then we're going to do bond line structure. So I got this skeleton, C double bond, C, OH. C double bond, C, single bond, C, OH. I'm going to bring this down here. No problem. C double bond, C, OH. Kind of know that's a single bond. So we have a double bond to the C. It needs 2 more. So that would be 2 hydrogen right there. We see this has a double bond and a single bond. It needs 1 more. There's my beautiful H. And this C, there's 2 H's on it. And then the O we know needs to be 6. Right now there's 2 bonds. So let's get 4 valence electrons on there. And now, maybe this can help. You can write the condensed form, CH2, CH, CH2OH. From that, let's get the bond line structure. So now I got 1, 2 carbons. Let's draw a third. So this carbon corresponds to right there. And we see that there's a double bond between this one, so there it is. That's too ugly. And that's even worse. C, double bond, C. So I got my 3 carbons, and I need my OH at the end. And we could even put our valence electrons. So now we're going to go 1 more, just to see that you're kind of getting what bond line structures look like. So, I'll draw it out for you. I got my CH3, CH2. Got an oxygen in the middle this time, and then an oxygen double bond with a CH3 at the end. So, maybe this helps. Go CH3, CH2, O, CO, CH3. So I'm going to get my I'll account for 3 different things. I like kind of doing that little zigzag, kind of helps me out. So at the end I have my carbon, and then I have a CH2, and then up at this end it's an O. Okay. I need another carbon, so I'm going to draw it in. Now there's 2 ways you can do it. We won't draw carbons right now. I got my carbon there, the end of this. Got 1 more carbon, and then I have a double bond O. So then, one other way to kind of look at this, you can draw your diagonals. You got your O. When things might maybe get confusing or you like to slow it down, I can draw my C there and kind of know where I am. And I know I have a C double bond O right here with its valence electrons. And then I can draw a C at the end. See, this is kind of like a hybrid. This would be a true bond line. Either way works. It's up to you, and that's it for a little bit of practice. Thank you.